Okay, your corrections will be tomorrow. Make sure you look through that stuff. This is a good thing, actually, if you think about it, because next week is your end of Chapter 7 exam, so everything from last week does not need to just be brushed under the rug. You're still accountable for it next week, okay? I also need you to know that if you didn't understand it last week, granted you've already tested over it, you still need to try to understand it between now and next week, okay? So please don't compartmentalize and shut that out. It still needs to be in your mind. We'll do corrections tomorrow. We're going to cover 7-4 today. Just one topic, practice it, and then we're done. And then we will finish 7-4 after corrections tomorrow. Then we have 7-5. I anticipate 7-5 to be 2 to 3 days, depending on how I split it up. And then, of course, you have now your My Math Lab homeworks for 7-4 and 7-5, okay? The end of Chapter 7 exam will also be on paper because I don't want the 1 or 2 from the mid-7 that will be on there, you know what I mean? I don't want y'all having to do those multiple choice and all that drop-down menu, explain your reasoning. So, and tentatively, the test for that is Wednesday, the 29th of next week, so that if anyone is absent that day by accident needs to be excused. I think I'm going to start a new policy where it's an unexcused absence can't make up an exam, because I need y'all to just face it, okay? Face your fears. But then I can catch them on the 30th. Does that make sense? Y'all with me? Or if you already took the test, y'all can sleep in on the 30th. Right, and then come in. Okay, so 7-4. We only have 7-4 and 7-5 to cover. You have your unit circle out. Before we dive right into 7-4, let's refresh your memory on finding values from your unit circle. So just look at your unit circle, answer inside your mind, give it a few seconds, and then let's just all answer as a group. Direct your eyes to the cosine of 5 pi over 4. Put your eyes on the cosine of 5 pi over 4. Are y'all looking at negative root 2 over 2? Okay. Put your eyes on sine 11 pi over 6. Sine of 11 pi over 6. Are you looking at negative 1/2? And if I said to look at tangent, is the answer for tangent on the unit circle? No. Tangent you have to calculate, right? And then sometimes rationalize. Tangent is what divided by what? Y over x or sine over cosine. Let's go with an easy one though. Direct your eyes to 3 pi over 4, and then now think of what tangent would be. Negative 1. Right? Because they match, but one's negative. Okay, so what you just did is the same concept we're doing today. Yay! We're flipping it. Instead of me saying, what's the sine of, what did I say? What's the sine of 11 pi over 6? Instead of me saying that, now I'm going to say to you, where is sine of some angle? So where, meaning tell me the angle or the radian measure. Where is sine of some angle negative 1/2? Well, that would mean you would have to look here and say to yourself, well, there's a negative 1/2 in the y position, and there's a negative 1/2 in the y position. So you would say, well, it's either 210 degrees or 330 degrees. That's what we're doing today. I'm going to say it again, just in case you didn't understand that. What we're doing today would be like if I said, tell me where on the unit circle cosine of some measure is what you're telling me, is negative root 3 over 2. So So you would go on the unit circle and you would find where all the cosine is negative root 3 over 2. Now, break it down. Don't look in all four quadrants because cosine is what value? X. And X is only negative if you go left. So there's no need to check quadrant 1 or 4. So that's where you start getting intuitive about it. And you think to yourself, well, if X is negative, that means I'm checking quadrants 2 and 3. And she said, where is cosine negative root 3 over 2? So the answer would be 150 degrees or 210 degrees. You would write both. Now, if I told you that you're in quadrant 3, then the answer would be just 210. Can you understand? That's the game plan. That's what we're doing today. The way that it's written looks really complicated at first, but I'm going to show you how to read it. And then I'm going to also show you how we're going to get around having multiple answers. Because we're going to practice at first addressing the inverse functions, and then we have to restrict the domains. I know that probably just sent like a chill down your back. But it's the same restriction every time, so I'm going to show you a technique for memorizing what quadrants you're allowed to answer from, and then we'll practice, okay? So, and I have a cute little person to tell me when to stop that will appear on the screen. All right, so let's first wrap our mind around the graphs real quick. There's not a lot to take note here. The top 3 graphs. You want to take your pencil and kind of box it in. The top 3 graphs. Can't do it. I'm sorry. I'm going to have to cheat. Here we go. The top 3 graphs. I just can't. My OCD won't let me leave it that ugly. These are the mother functions. S. There's an S. Those are the mother functions. You've got the graph for sine, the graph for cosine, and the graph for tangent. The little purple bar, the horizontal line on each graph, is showing you a random horizontal line drawn to prove to you that it does not pass the horizontal line test. Go back to college algebra. We learned let me back up even more. Go back to Algebra 1. You learned the vertical line test. Vertical line test is a fast, quick way to determine if a graph is a function. Function, let me go back even more. Function means if I say, hey, evaluate this equation at this number, it means you're only going to come to one answer. So that if you plugged 4 in and you plugged 4 in, y'all didn't get 2 totally different answers, but you did everything right. That's not a function. A function would be, say, plug 4 in and everybody should get the same answer. One answer. Okay, so that's what a function is. Okay, vertical line test is when you take a graph and you can determine if it's a function by just looking to see, does it pass the vertical line test. Horizontal line test is taking a graph, looking to see, does it pass the horizontal line test. If it does, it means, follow me, the inverse graph is a function, which means it would pass the vertical line test. If it fails the horizontal line test, it means the inverse graph will not pass the vertical line test. With me? That fails the horizontal line test. It's passing in more than one spot. So if I graph its inverse, which coincidentally is right below it, it's going to fail the vertical line test. Do you see that? That's a problem. Somebody, however many years ago, somebody said, well, that's no fun. I want to be able to evaluate the inverse of sine, cosine, and tangent. So instead of just saying, well, I can't do it because it doesn't pass the horizontal line test, let's restrict the graph to just a certain section, and then I can do it. Thanks to whoever said that. Okay, so these are your three mother functions that you already are familiar with, and you'll notice they all failed the horizontal line test. These three right here, where'd it go, are your inverse functions. And you will notice that they all fail the vertical line test, which makes sense. So we're going to say inverses, and then I'm making a note of fails vertical line test. I'm going to put V test. Because I don't have a lot of room. Y'all have that nice little margin. I can't do that. So someone said, well, that's not fun. Let's restrict the domain. And then that way we can actually evaluate it. Just like with you have a quadratic. That's why this says review. When you have a quadratic, if you look right here in light gray is the mother function of a quadratic. And then the inverse is the yellow one. Notice the yellow one fails the vertical line test. Well, if you restrict it, the inverse of squared is square root, and then you just say, hey, you have to stay positive, 0 or positive. Then you get this purple line right here, and now it passes the vertical line test, so that's a restriction. That's what we're going to do here. Good news is, these restrictions, I'm going to show you a way to remember them. If you have a highlighter, it might help here. We have a couple of notes to take on this slide, and then we're going to dive right into practicing. First of all, let's refresh your memory on inverse notation. Inverse notation looks like this, sine inverse. The little -1 up there does not mean an exponent. It's the notation for inverse. Let me introduce you to a new way to see it. This is the college level. It is the word arc in front of it. Arc sine. That is the college level notation for inverse trig. Why is it the word arc? I have no clue. I don't know. But all it means is inverse. Okay? And I'll be honest with you, I'm not very good at using the arc notation because it bothers me. I don't know why. I know the -1 means inverse, so I usually stick to the -1. You may see arc in your My Math Lab homework. Just change it to the -1 if it bothers you, okay? All right, so here's what we need to highlight so that you can wrap your mind around what we're doing. I copied all three. This is a very crowded slide. Sorry for that. I copied all three inverse graphs right here. And now on mine you can see the colors. On yours I know you can't see the colors. I want you to highlight the little purple or pink, whatever you want to call it, segment that's in the middle of my yellow graphs. So like right here, here, and then this one. Do you remember the vocab word for the dotted lines in the tangent graph? Do you remember what those dotted lines represent? Those are asymptotes. So just maybe write right here, that those are asymptotes. They don't come up in this because we're going to stay between two asymptotes. I just want to make sure you remember what they are. So we're going to highlight one more thing, and that is this nice chart right here is telling me exactly what sine, cosine, and tangent are going to run between, and then it's telling you what all of the possible answers would be between. So when we evaluate sine inverse, we're only going to focus on -1 to 1. -1 to 1. When we evaluate sine inverse, we're only allowed to plug in values between -1 to 1, and we will only come out with values from -π/2 to π/2. I'm going to show you what this means in terms of a graph in a second. When we evaluate cosine inverse, we're only allowed to plug in values from -1 to 1, and we will only come out with values from 0 to pi. We won't have any values outside of that. Now tangent, because tangent, look at the graph, the inverse graph of tangent. Notice it had arrows, right? That means keeps going, which means there's no bounds, right? So right here, what can you plug into the tangent inverse? You can plug anything in that you want because it keeps going. It's covering the entire x-axis, right? But what is the only possible output? Well, that's where you turn your head sideways and say, oh, well, I'm only going to come with an answer that runs from -π/2 to π/2. I don't expect you to really know what I'm talking about just yet. Let me show you, let me put it into practice for you in a second. So this part down here is where I just took what I just said and I put it in a nutshell, kind of like Cliff Notes version, down here. So this is the actual graphs of the inverses that we're allowed to look at, because everything else beyond it is outside of our restriction, which means that's where you run into that failing the vertical line test problem. So if you notice now, this is the snippet, the restricted graph for sine inverse. Does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. So that's why we're allowed to do that. Like, that was the goal. Look at the cosine graph. Passes both vertical and horizontal. Look at the tangent graph. Passes both vertical and horizontal. That was the objective. Because now, if I keep this in mind, then I can evaluate the inverse functions like what I was practicing with you at the beginning of the lesson. Okay? Down here you see where we have copied the domain and range, which was right here. I just copied it and I wrote π/2 in fraction form instead of written out like that. Now, what does this translate to in terms of a visual? Here's your visual. Here's where you're going to want to highlight. The sine inverse answers, right, will only come from quadrants 1 and 4. The sine inverse answers, the answer, right, will only come from quadrants 1 and 4. Notice right here it says the range for sine inverse is -π/2 to π/2, which is exactly what you just highlighted. The cosine inverse answers will only come from quadrants 1 and 2, or 0 to pi. The tangent inverse answers are just like the sine inverse, and they will only come from quadrants 1 and 4. There is one small restriction on tangent. Tangent has one problem. And I need you to take your pencil and draw really dramatic, because I don't know if you can see it. Can you see it? No, you can't. If you have a black marker, you might want to take a black marker or something, or your pencil, but draw really dramatic, open circles right here. Open circles. Maybe even draw an arrow to yourself. Open. That's not a very good arrow. Draw an arrow to yourself, but those are open. Look at the range right here. Notice it's in parentheses. Then look at the range under sine inverse. Notice it's brackets. Notice brackets, brackets, then tangent has parentheses. Okay? Let's make a note here. Memorize this. You need to memorize this before the next exam. Not that bad. When you first look at it, you're probably thinking, good grief. I'm going to show you, like when we get to the next slide, how to copy it over. Now, I've explained everything. Now, and you have a visual. Now let's put it into practice. And then we have 3 slides of practicing. The first slide is just very easy. The second slide is where you have decimals, which is nice because this is where you actually use the calculator. I love those. And then the last slide is where we go back to practicing what we're about to look at to make sure you understand, and then we're done. Okay, so come to this slide right here. Oh, there's only 2 slides left. I think I said there were 3. There's 2. Find each of the following function values. Notice it says nothing about rounding to a certain decimal place. This means they want exact answers, and it means it's coming from your unit circle. Okay? That's your indication that this is exact. You have to find it. This down here, notice it says 4 decimal places. That's your clue. This is calculator. Okay? All right, so looking up here, find the function value. Notice right here, this says little -1. This says -1. And this says -1. That means that I'm not just saying to you, where is sine, what's sine 30? And then you say, maybe do the circle. Sine of 30 is 1/2. That's the old way, right? Because I have the -1, that's the equivalent of me saying to you, now I'm going to give you the point value, and I need you to tell me the degree measure or the radian measure. Let's go to the top of the page and make sure you remember. Sine means which one? What letter? Y. Cosine means, and tangent means y over x, right? You will notice that I put these in the exact order of how we learned them on the last slide. It's sine, cosine, tangent. So when I say memorize, and what I was talking about on that last slide, you would come right here on your formula sheet for this end of Chapter 7 exam, like as soon as I hand you the exam or the formula sheet, I would go to my paper and I would draw my 3 coordinate planes, and I would remind myself that sine runs from here to here, cosine runs from here to here, tangent is open from here to here. Then I would even take it a step further and label those. Now, if you need to label them and you don't want to label it from memory, it's on your unit circle, right? What is this up here in degrees? This is what? This is 90, right? Now, this is I guess, a trick. I don't want to say it's a trick, but this is be careful here. If I'm rotating from here to here, this down here is not 270 in the manner that it's showing. It's actually -90. Okay? Because it didn't rotate in a positive direction. It's going from, I'm backwards, hold on. It's not rotating from the initial side like this. It didn't go that way. It's going from 90 down, which means that this will be deemed as -90. You with me? Same thing over here. This is 90. This is -90. Now this one's easy right here. This is what? 0 to 180, or you can write pi. I should have changed that. You can't see that. That says 180. Okay, so we've got our reminders of which value refers to what coordinate point. We've got our 3 graphs drawn to help me determine what quadrants I'm allowed to be in. Now let's practice the actual question itself. Let's read it. It says sine inverse of root 2 over 2. I want you to write this, even if you already understand it. I want you to write this. What angle has a y value of root 2 over 2 within sine inverse range? That's how you ask yourself the question. It's saying, what angle on your unit circle has a y value of root 2 over 2? The trick is, it's not all 4 quadrants that you can check from. You're only looking in quadrants 1 and 4 because we're looking at sine. Okay? These little graphs are narrowing down from having to check 4 quadrants to you're only checking 2 every time. It's just which 2 are you checking? Well, if it's sine, you're checking 1 and 4. If it's tangent, you're checking 1 and 4. If it's cosine, you're checking 1 and 2. With me? Yeah. All right. So look at your unit circle right now. Everybody go to it. Now I can do this with mine because I can easily erase my highlighter. This was a sine inverse question. Sine runs from 90 to negative 90, right? So between quadrants 1 and 4, find your eyes on the y value root 2 over 2. Put your eyes on the y value root 2 over 2 in either quadrants 1 or 4. Did you go right here? Is that where you were looking? So the answer is 45 degrees or pi over 4. I wrote both, just to show that it's either or. I don't know, I don't remember off the top of my head what my math lab is going to ask for. So we would say right here that, and I'm just writing the problem again. You don't have to if you don't want to, but the y value of pi over 4 is root 2 over 2. The y value of pi over 4 is root 2 over 2. Okay, let's go to B. Now, you don't have to write that out again, but let's say it out loud. What angle has a what value? What's cosine? Cosine is x. So what angle has an x value of negative 1/2? I'm only allowed to check what quadrants? 1 and 2. Right? So go over here. Let's clear our screen. We're checking, this is cosine inverse, so we're checking 1 and 2. What angle has an x value of negative 1/2? Did you put your eyes right here? Yes? So the answer is 2 pi over 3 or 120 degrees. Tangent. Tangent, once again, is the more challenging one because it's not where you can just read it from the unit circle. You have to actually calculate y divided by x. So let's write this out. What This is going to get crowded. Don't write big. What angle has a tan value? Notice I didn't say an x value or a y value. I said a tan value. Now in parentheses, I'm going to put what tan comes from. Tan comes from y over x. And the goal is we want it to be negative root 3 over 3. But we have to stay within tan inverse's range. So that's a mouthful of a question. What angle has a calculated tan value, so y over x, of negative root 3 over 3, but only within the tan range, which means you're only checking quadrants 1 or 4. Okay, so we're looking for negative root 3 over 3. That tells me I'm in which quadrant? Because it's negative. I'm in quadrant 4. So when I look at this, I know that because of the little memorization part that I told y'all to memorize, I'm only checking quadrants 1 and 4. But because tan is negative right here, that tells me I'm in quadrant 4. Okay, if tan had been positive, I would be in quadrant 1. So now we've narrowed it down to just one quadrant. So I'm going to go over here to my unit circle. Now I'm going to just highlight right here since we've already decided that we're in quadrant 4. We know it's not which one. I'm going to black it out. We know it's not this one, right? Would you agree? And we also know that, remember, the tangent had open circles on here and here. That means that these specific quadrantal angle points are not allowed to be in, like they're not included, because the open means don't touch this, right? Okay, so now we've narrowed it down from 2 quadrants to 1 quadrant to 2 choices. You with me? And the goal was, remember the goal, it was tan inverse negative root 3 over 3. Yes? Okay, so we have 2 choices. Remember, tan comes from y divided by x. And this is telling me that when you do y divided by x and then rationalize, you would get negative root 3 over 3. You see that? Because tan is y over x, and this is saying you should get negative root 3 over 3. Do you see a 3 in the bottom of either of these coordinate points? No, there's a 2, which means at some point you divided something, the 2's canceled, and then you had to rationalize, right? So y'all should be familiar that this came from having this as an answer, and what had to be done to it? It had to be rationalized. You with me? This had to be rationalized to yield that as an answer. So now you just look at them and you ask yourself, okay, well, if I did y over x right here, if I did negative 1/2 over root 3 over 2, what would I get? If I did negative root 3 over 2 over 1/2, what would I get? And then you just check it. So, looking at this, you can actually check this in your calculator if you wanted to. Just check the decimal. So, negative 1/2, if I kept that, changed, and flipped this, I'd end up with root 3 in the top, wouldn't I? Do you see that? Negative. I'll just come right here. I'll just write over it. So this is right here. This is you visualize. Keep, change. Actually, it would end up in the bottom, right? 2 over root 3. Now let's check this one. Keep, change, flip. You see that? Which one's going to end up with this? The 330, 11 power of 6. Do you see how that would end up being? And then you would have to rationalize and you'd end up here. The good news is you wouldn't have to do this on every tangent problem because there's only one of two options, right? So you do it one time, then you know the other option is where there's no rationalizing. It's nice and pretty, root 3. So let me recap what I just did because I feel like I've already lost a few people. The problem said what angle has a tan calculated value of root 3 over 3. Tan is tricky. Tan is y over x. Well, the inverse tan range is 90 to negative 90, right? So that tells me I'm in quadrant 1 or 4, but because it was negative, that tells me, okay, so I'm in quadrant 4. I also know that it's not the 7 pi over 4 option because that tan is negative 1, right? So that means it's one of these two. So I literally just very quickly did a keep, change, flip, y divide x of both of these to see which one yields square root 3 over 3. And that's how I determined, after all that, I determined that it's this right here. Yes? I feel like Billy Mays. But wait, there's more. There's one more thing. That is the answer. Like, it's 330, it's 11 power of 6. There's one problem. Go back to your picture right here. You see how we said that the answers can only come from 90 to negative 90? What did we say, 330? Is 330 in that window? No. So, once you find, so make a note to yourself right here that it was 11. It's 11 pi over 6, or 330 degrees, and I'm going to put in big letters, but, dot, 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 dot. That's not allowed in our range of numbers. We're only allowed to go from 90 to negative 90. So you're looking at that reference angle. Okay? So you just go back here and you say to yourself, 330 is what reference angle in terms of negative from 360? Negative 30. Do you see that? If you're going from the initial side this way, it's negative angle, and the gap from 330 to 360 is 30 degrees. So the correct answer is negative 30 degrees, and then to get the radian measure, just look up here at what the radian is for 30, and just make it negative. So it'd be negative 30 degrees or negative pi over 6. Okay? So the answer is negative pi over 6 or negative 30 degrees. Now, when we take this test, if you put that as your answer, you're just going to lose a very small partial credit because your answer's right, but you just didn't remember it has to stay in that range, okay? All right, so let's take a second mind break from having to actually find it on the unit circle. Let's let the calculator do the work. Get your calculator. You have 5 practice problems here. It says approximate both radian and degree, and they want it to 4 decimal places with radians. Degrees go to the nearest 10. All right, so let me pull my calculator up. So what I would do is put your calculator in radian, and then just find the radians for the trig functions, and and then go back and you can find the degrees. Or you can switch between. All right, I'm already in radian. Okay, so because of the little -1, that means you have to hit the second button to get cosine inverse, and it's negative 0.2689. We're going to the nearest 4 decimal places on radians, so the answer would be 1.843. And I'm just going to write next to it RAD. 1.843. Now, what would that be in degree measure? You would have to, you could either change your mode to degrees, or what's that easy conversion? If we're going to degrees, we multiply by 180 over pi. You don't have to go that way. You could just change the mode on the calculator. And you get that the degree measure is 105.6. So I'm going to put degree 105.6. Now, how did I go from here to here? You can either change the mode on the calculator, or you can multiply by 180 over pi without having to worry about changing the mode. Second tan, negative 0.2565. Oh, sorry. Second tan, I was writing the answer. Negative 0.2623. So then just multiply that by 180, divide pi, and you'll get the degree measure without converting, like the mode of the calculator. So negative 14.7 degrees. What happens when you enter D in the calculator? Look what it tells you. There's a reason for that. You would make note that this is just undefined. And the reason is because sine and cosine, if you think about, go back to geometry, those are adjacent over hypotenuse or opposite over adjacent, or opposite over hypotenuse. What's the length of the hypotenuse in terms of the triangle every time? It's the longest, right? So sine and cosine can never be higher than 1 because the hypotenuse is always in the bottom of a fraction. So that's why that one ends up being undefined.
So E is also undefined?
Well, E is cosecant, so you would rewrite this as sine of some angle is 1 over 8.205 because it's the reciprocal. So you would evaluate in your calculator second sine 1 divided by that.
Oh, so sine goes twice and 1 over.